Hello everyone, and thank you very much for being back here with me. Today we continue our discussion about the Spring Start Here book. We are already at chapter 12 and today we start discussing about databases, and there are 3 chapters on databases. I will explain you why I chose this structure. When writing the book you will see it makes a lot of sense. It's very important to take the things from the very beginning up to the more complex things, and without this you will know all the essentials. So stay here with me. Thank you very much for being here with me, and I will already share you my screen to see what I'm seeing in front of me. Remember that you have a live chat there, so you can already start the discussions and asking the questions in the live chat. And of course you can always find me on social media as well. Remember to subscribe to the channel and continue watching videos here. You will find a lot of content, plenty of content on Java related stuff. With that being said, I think we can already deep dive into this chapter, and again I'm going a little bit back on the table of contents, and I want you to observe that we are here at chapter 12 where we start discussing about data sources and databases and persisting data, and implementing the persistence layer in your application. But then we will continue with chapter 13 and with chapter 14, and they are at the same time also about persisting data. And then you will wonder why I've used so many chapters in discussing this topic. And this is because today we will start with the fundamentals, with the low level stuff, and then only in chapter 14 here we will discuss about abstractions such as Spring Data. And this is really important because you will see I have this experience today. In many cases I see especially entry-level developers jumping straight into Spring Data, and they don't understand Spring Data either. They don't know anything about what's behind the scenes. They have no idea what they are using, and they only have a feeling of what can I copy paste for it to work. And this is not the way a real developer works. This is not the way in which a professional developer works. So you have to think about yourself as being the mechanic and not the driver of a car. No, if we make an analogy with a car, if you only go into Spring Data directly, you have a feeling of what you have to do to make the things work, but you don't know anything about what's behind the scenes and what actually builds that technology you are into. Then you are the driver. You are not the mechanic. The mechanic is the real developer who knows what behind the scenes, who knows what to troubleshoot when problems occur, who knows what to take on into consideration from the very beginning when building applications so that it makes them performant, secure, maintainable, all the non-functional requirements together with the functionality itself. And you cannot achieve that level unless you know pretty well what's building that technology that you are using. So this is why I have invested so much time in so much space, and time into building this part of the book, where I start with the basics and I progress up to the abstraction layer such as Spring Data, so that we correctly understand them. With that being said, I think I can actually already jump into what I want to teach you. And in this chapter, so we start with the very behind the scenes. We will start with actually discussing what a data source is, and then how do you configure a data source in a Spring application. And then I will use the simplest, most low-level capability that Spring offers to connect to a relational database, which is called the JDBC template. Nowadays we do not use the JDBC template anymore. I do not recommend you using it anymore. So it's here with the purpose of showing you the behind the scenes, the insights that you need when you will be able, when you will need to troubleshoot things, and you will need to be able to implement scalable solutions, performance solutions. Think about what you build there and not only build something to work like a real developer does, like a developer that now knows how to build performant applications and real enterprise applications, because this is what Spring is made for. So with that being said, in this chapter now we've already discussed, but as a reminder for you now, in this book we have already talked about a lot of things now, and in the past chapters you've actually learned about communication between services. We talked about the REST services, how to expose an endpoint, how to consume an endpoint with different approaches. Now we are here, now we are at the moment where we start considering that our services have a persistent layer, and that's what we talk about now, about the persistence layer of your application. This is why this is pointing to the database. The cylinder now is the representation of the database and says you are here now. So in this book we've reached this place where we've already learned about the communication between applications, including the client and services, backend services behind the scenes. Of course, we didn't touch integration patterns such as API gateways, such as load balancers, circuit breakers, retries. Those are more advanced stuff. This is the Spring Start Here book. Here we discuss about the essentials which you need before jumping into more advanced things, more design-wise things or architecture-wise things, such as microservices patterns versus service-oriented architectures versus monolithic, modular, monolithic. This is before you can jump into that. You need to know pretty well how to build the stuff, no? So that's why here maybe rendering this doesn't really look like a normal system. No, this looks like this client here jumps directly into one of the microservices behind the scenes. This is because this book is not about patterns of architectures. It's about the using Spring, the very basic stuff that we are teaching here. So with that being said, let's jump into what we are interested mainly. Again, very important. I want you to know all the steps that happen behind the scenes when your application sends a query to a database. So you have the database management system, DBMS here. It holds your databases with their schemas, with their structure, with everything. In order to work with it, what a Java application does, regardless it's Spring or any other framework, is to send SQL queries to the database. And in the end, in a way or another, regardless on the technology that you use for your persistence layer, your application will send SQL queries to the database, and it needs to send them for exactly the technology you use for your database. So if you use Postgres, then the syntax should be understandable by Postgres. If you use Oracle, then the syntax should be understandable by your Oracle server. If you use MS SQL, by your MS SQL server. If you use MySQL, by your MySQL server, and so on and so forth. So how does a Java application achieve this? First of all, it needs to have the implementation specific to that database technology. So you see here this from the right, from the right to the left, this rectangle here, white rectangle called JDBC driver. This is basically a mandatory thing for any application that connects to a relational database. It provides your application with the implementations needed to connect to that particular technology of your database. And then you will always have in a real world application a data source that uses the JDBC driver. In the when you learn the fundamentals, when you learn the Java fundamentals, the very basics, you skip over the data source. So that's why I'm emphasizing this data source in this chapter, in this first chapter where we talk about database connection here with a Spring application, because I know that always in the fundamentals this data source object is kept. So what happens when you learn about JDBC within Java fundamentals for your OCP exam, for example, usually you use that driver manager class. So if you've already learned, and I hope you did already learn the Java basics, if not, you can always go back on the playlist about Java fundamentals on this channel and start all over with that, because otherwise you will not understand what we talk about in this series. So when you've learned about the Java fundamentals, you've learned about driver manager get connection, and then so you were calling that get connection static method, providing usually the credentials, getting back a connection object. So that is basically skipping over the data source. What the application does there is to directly use the JDBC driver. But this is never what we do in a real world application. Never, because if we would do it like that, then we would have to manage the connections ourselves. So make our application logic manage the connections. And this is not efficient. It's not really something you want to do, because you cannot borrow an infinite number of connections. So what the problem with connections are is that the DBMS, the server hosting your database, will always provide you with an amount of connections which is configurable at the server level. It will be a finite amount. The server will make sure that you not abuse of the connections. And then if you borrowed too many connections and you ask for another connection, then it will tell you, hey, wait, you have first to give me back, meaning close one of the borrowed connections before I can give you another. So all this management needs to be done somehow by your app logic, so that it doesn't run into a situation where it requests more connections than it has. And moreover, what an app should do always is not open and close connections all the time. If you have your application calling driver manager get connection and then closing the connection, and then do that again for any query, then you will send a huge number of network requests, which will end up in a very poor performance, because every connection retrieval, it's an IO call. And what do we know about IO calls? We know that they are slow, that we try to avoid them because they always run over the network, and they can be blocking. The more IO calls your app uses, the worst performance will you have. So then what's the better approach? The better approach is that you reuse connections that you have borrowed. So instead of borrowing and closing, borrowing and closing, borrowing and then closing, you borrow and use a connection as much as possible. And this is exactly what a data source is. So what a data source object actually is a manager of the connections. It manages the connections in an intelligent way, such that your application is performant, stays performant, and doesn't reuses as much as possible its resources without having to very oftenly request new resources from an external dependency such as the database management system. So this is why in real world applications this object called the data source is very important. With Spring applications today, the default that we use is the Hikari connection pool. That is the database object you will find with Spring Boot provided by convention. It's an excellent connection pool, an excellent data source, but you need to know that it exists and why it's there. No? So your app logic will always request the connections actually from the data source, which will manage the connections through the JDBC driver. Okay, that's what this figure 12.2 tells you at the very end. So now going a little bit deeper in the JDBC driver, when I say app here, it doesn't mean app logic like here, it means actually app together with its data source. No, so the data source we consider part of the app, and then the data source uses what exactly? What do we use from the application? Do we directly use the JDBC driver, as you might understand from the previous diagram? No, it's not directly the implementations. The JDBC part of the JDK is made in a very wise way. It's defined to contain in the JDK only abstractions, meaning interfaces, contracts, no, so that your app uses the connection, result set, or statement types. But the JDK doesn't tell you which implementation, because your app needs to be able to connect to a variety of technologies here. A Java app needs to be able to connect to Postgres, but it needs to be able to connect to MySQL as well, and so on. And then your JDK cannot contain all the possible vendor implementations. No, it wouldn't even make sense to link the Java versions to database vendor implementations. And then how can you decouple? What is the main way to decouple things in Java application? Through contracts, of course, interfaces. So instead of providing you implementations, the JDK provides you abstractions which you can use. But then you need to make sure that you always add the proper implementation in the class path. If you don't do that, nothing will work, because you can not only rely on contracts, you will need to have an implementation for those contracts. That's why we always need to have a JDBC driver in our class path, which is according to the technology that we use. So, it actually is someone says that, let me see what the problem is, that you actually only see the first part of the chapter, which is interesting, because I am displaying diagrams, so apologize for that. Let me see if I can fix this quickly in a way or another. Okay, so maybe something changes now for you. So hopefully it will you will soon see the updated stuff, and I'm gonna try to go back on my diagrams I was explaining at least quickly so that you understand. Thank you very much for pointing that problem. I'm still not sure this will Okay, I will try restreaming this. Apologize for the problem. Okay, I think now you see actually it's better what you see, so you should be able to really see what I'm showing. So this was the first diagram. So apologize for this for this delay, and thank you so much for being attentive here and telling me that something is wrong. So this was the first diagram. Now I was saying that the app logic is connecting to a data source which was connecting to a JDBC driver. No, so the JDBC driver is used by the data source to obtain the connections and everything, but then the data source is the one managing the connections. And then this was the second one, which I was actually discussing at the moment I saw your message, and that is we have the abstractions in the JDK. The app uses the abstractions, but it needs in the class path to have the appropriate implementation, otherwise it doesn't work. No, so that's why if you forget to put the driver in the class path, it can't work even if your code compiles. And then secondly, this is why you will see if you are using Maven or Gradle, for example, which we kindly use very often with Spring and Spring Boot, is that the JDBC driver is set as a runtime dependency and not a compile time dependency. Well, it's not mandatory that you put that tag, but it only makes sense usually to have it at the runtime, because that's basically when it's used. No, the driver is not used for compilation. It would be even wrong if you would use directly classes from the JDBC driver. Never do that. No, if you see something like that, that's wrong. Okay. So I'm going, and now at the beginning of our discussion, now I was telling you about the driver manager get connection. Now this is how you see it. No, and now I was explaining you, this is what you learn as an entry level. This is what you learn in the fundamentals of Java. No, driver manager get connection. This is something that you can even have in OCP questions, but this is not what you will have in a real world application. That's why we have the data source. What the data source does is basically, you can imagine somewhere behind the scenes, it actually does exactly this. It gets the connection, but then it keeps the connection, and depending on what data source implementation you have, it will close it or not at some time. It will manage these connections properly, so that you don't have to reacquire them again and again. So from this first part, this first section of this chapter, what I want you to remember is what a data source is for, why do we have it, and what is the relationship between the application, the data source, and the JDBC driver, and how does this happen. No, so it happens first of all at the level of the JDBC driver only through abstractions from the JDK, and then when your app uses the connections, we'll always retrieve them through a data source, which is a manager. And then is Hikari a data source? Yes, Hikari is actually the Hikari connection pool. No, that's how that's the complete name, Hikari CP. That CP, it comes from connection pool. It's actually a data source, and is the convention data source with Spring Boot. No, so you can of course change it. The data source has a very nice interface as well in Spring, which is called, guess what, data source. And you can provide any implementation. Even theoretically, you can even provide your own data source implementation if you like, but naturally you will not do that. You will use provide implementations such as Tomcat connection pool or Hikari connection pool, which are basically the most known. I think Tomcat was actually default in Spring Boot 2 before Hikari was made a convention. Anyway, probably there are multiple. You can use either, you can replace one with another, but in 99% of the cases, likely you will go with the convention, which is Hikari connection pool. Good. And then the demonstration. Now, how do you actually send SQL queries to the database management system in the simplest, most low-level way possible in a Spring application? Well, you actually can use the JDBC template tool. This is a very verbose tool, difficult to use, with quite a lot of methods, and I do not recommend you use it anymore today, but you will still probably find it in older applications, and at the same time it offers, let's say, a possibility in some cases to do some more low-level stuff. However, I do recommend you understand it only for practice, but then today we do use, in the majority of the cases, abstractions, and in Spring we have this Spring Data project which provides multiple modules depending on the kind of persistent technology that you want to use. And when we will reach chapter 14, I will teach you how to use Spring Data properly, but then I will always refer back to chapters 12 and 13 just to make you aware again about what's the behind the scenes, because what I want by the end of this book is that you don't only know how to implement something that works, but you also know what's the behind the scenes, and you are able to troubleshoot it, and you are able to understand if you are doing it in the right way and spot problems preferably before they reach your customer, before they reach production. So even if JDBC template is not something that I recommend you now work with directly or use it directly in your applications, unless it's an older app that already uses JDBC template, it's a way to see easier what happens behind the scenes. So now this snippet here, this listing, you can see this shows you actually how a Java application can connect to a database management system without absolutely any framework. No Hibernate, no Spring, no nothing. And why is this important, and why did I start this section 12.2 with this code snippet? Is because what I want you to understand from here is also the evolution. Usually the evolution helps us spot problems and imagine how developers started with something and then how did they progressively enhance that technology to make our lives easier. So you might be an entry-level developer, and now today you start directly with Spring Data and you see some very simple non-verbose way of working with the database, but you don't really understand how things were before and where did that come from, and how does it actually help in the end. That's why one of the things I want to make you aware of is what problems did the newer technologies solve, and how did they improve our experience as developers, but at the same time keeping the things that were all behind the scenes, so they are not actually completely replacing this, but this is actually the behind the scenes of any persistent technology, let's say relational database persistent technology in Java. So with that being said, so let's take a look over it. Now, how were we doing? We were defining basically the query to be sent, and then we were obtaining from a connection. Yeah, that one obtained either from the data source or from the driver manager. No, we were obtaining a statement. We were setting the values. No, for each value we had to define it, and then we were executing a query or an update, and then we had to catch this SQL exception, which is one of the worstly defined exceptions ever in Java. First of all, because it's a checked exception, so you have to treat it regardless you care or not about that particular situation. And secondly, it's because it represents all the possible situations that can be exceptionally with connection to a database. It can be you have you have the wrong credentials, or it can be the query is not written correctly, or it can be the data type is not good, or it can anything. It can be anything. Trust me, it can be 1,000 things, and they all will lead into an SQL exception. This is why SQL exception is bad. So what Spring actually did, one of the things that it did, I'm not sure if it's written here precisely or later on, but instead of having one SQL exception, Spring defined segregated exception types for each of the essential things that can happen when working with a database management system. And more than that, those exceptions are runtime exceptions. So you are not forced into treating something that you might not even care, might not necessarily need to treat. Like, for example, the fact that the query is written correct or not. Maybe it doesn't really make sense in this case because it's directly written in the code and it's not something that it's inputted. So in this case, why the heck do I care to treat that exception? I know that it's always correctly written because it's there hard-coded in my code. No? So the way SQL exception worked is it wasn't, let's say, the best approach ever. So Spring tried to solve this again by segregating into multiple runtime exceptions, allowing you the segregation principle, allowing you to only use what you need, not being forced into treating all the possible exceptions you don't actually, that might not even occur, that might not ever happen. I see a question. Will the data source handle the connection closing here? I forcefully shut down my application. I think it depends, actually. Depends on what means forcibly shut down, because if you actually kill the process, I don't think there is any logic executed anyway behind the scenes. So in that case, probably not. But that's why there is also a timeout on the connection. So at the database management system, you also need to correctly configure some timeouts for your connections for idleness of the connection. If it's just simply like you have an executor service and you shut down, then yes, because that is an elegant way of shutting down the application. So the answer to your question is it depends. It depends on what, from your perspective, forcibly means. If it's like killing the process, then no. It's not about the data source. It's about your application. You cannot do anything. It's not that the data source is just an object or a capability of your application, but the application will be the process will be completely shut down. So it's not something that it can do anymore itself. Now, if you kill the JVM, you kill the JVM. So, and then another very good question. Now we are going back to the exceptions. Under the hood, they are using JDBC templates. So how does Spring convert them to runtime exception? Well, that's actually an excellent question. Well, you can easily convert to runtime exception by treating an exception and then throwing a runtime exception. Now, if you use a try catch, but from the catch you throw a runtime exception, then you have converted a checked exception into a runtime exception. And then inside the SQL exception, actually, the SQL exception has a code. If you will take a look inside, I don't have now an IDE open, but you can do that. You can take a look at the SQL exception. You will see it has a code. that code basically identifies the error that happened. So this was basically how you would differentiate between if it's a wrong credentials problem or a wrongly written query. So what Spring does behind the scenes is to implement some logic catching the SQL exception, comparing the code, and then rethrowing another exception, which is runtime. That's how it does basically. Cool. Okay, so of course I do actually provide an example. I'm not gonna go through all the details of this example. It's a very simple one. Now it's kind of a controller using a repository that connects to a database. I want you to pay a little bit of attention. This book is not always, sometimes it simplifies the examples to make them focused on what it teaches, to allow you focus on precisely the teachings. So normally remember that a controller will never call a repository directly, but since I'm discussing about transactions only in chapter 13, which is the next one, and transactions are the ones that we put at the service level, then I preferred to simplify here the example and directly create an endpoint that calls the repository. Okay, so that's why my example looks like this, to be simplified and not to complicate, with unnecessary things, because I want you to learn something. And then you see the dependencies I'm using here. What do I use here? So I'm using the, of course, starter web. We already know from chapters 10 and 11 what it does. It helps us providing with the tools we need to build endpoints or consume REST endpoints, and web pages, of course, at the same time. We've discussed this in the previous episodes. And then we have the Spring Boot Starter JDBC. Be careful, it's not the Spring Boot Starter Spring Data Starter JDBC. Is the Spring Boot Starter JDBC plain vanilla. So this is not a Spring Data dependency, but a Spring Boot dependency, which comes with what you need in terms of tools to connect to a database, but that's low-level tools to connect to a database. And then, because I need something to work without needing to raise Docker containers or databases or stuff like that, because I wanted to simplify as much as possible the book, I decided to use an in-memory database. H2, it's an in-memory database. It's very useful with examples and tutorials. Sometimes it's used with testing, but I will tell you more about that in chapter 15 when we discuss about testing, integration testing. I'm not always recommending H2, but again, a longer discussion, and I want to focus now on our discussion. And this should be everything you need. It should be everything we need to demonstrate how can we easily connect to a database through a data source. I'm actually creating only one very simple table called purchase. You can see it here. So I have placed my DDL script into the schema XML file. Now I have this example. By the way, all the coding examples, they are free, and you can find them on the main page of the book on the Manning website. So if you go on the book's main page, somewhere on the left side, if I correctly remember, you can download all the examples. So you can even use this chapter 12 example 1 yourself. Take a look on it and run it by yourself if you want. And then of course, then we start with the implementation, which I always start with having a model class that maps the database. Remember, we implemented model classes also for endpoints. We call them DTOs, or data transfer objects. And now you will learn that we actually have model classes that we implement for mapping tables or documents in a database if the database is a non-relational one, and we call those usually entities or documents depending on the case. So this is an example of an entity. Now many developers make confusions believing that entities are always only about JPA. This is wrong. Entity is usually the name we use for a model class, which is a mapping a table at a database level. It's not even a table, it's actually an entity now, because you have the name ERD, if you remember, entity relational database diagram, sorry, entity relationship diagram. So that means we refer to those entities, and usually the tables that are just for the relationships, no, for the foreign keys, they do not represent entities themselves. So the entity has a meaning of also some representation of some object, being it abstract or not, no. So this is an entity, and it's a model class because it's modeling something. In this case, it's modeling a purchase which has an ID, a product, and the price. So some more questions. Can you answer shortly what to use for testing if not H2? H2 is not the greatest thing to use. I will quickly answer you. Test containers. Test containers, it's the first approach I would recommend today for integration testing with the database. The second approach I would recommend is directly going to a test environment, but that has its problems usually derived from the network. I will explain again later because it's a long discussion. I think only the third approach will be H2, and I will use it very carefully, only with very simple things, only with very simple use cases. You have to be very attentive where exactly you use it. But to answer you quickly, the first choice for me would be test containers. And then, are DAO and model the same? Nope, no, they are actually not the same. Be very careful. DAO is data access object. Actually, DAO is kind of the same with repository. So repository, you can always also name it a DAO, data access object. So you could have been here purchase repository or purchase data access object. Okay, repository and data access object are basically the same from this point of view, but the model is the object modeling the data. Can we build massive application using Spring Boot also? What's the best approach to learn this framework? Well, I'm not sure if there is a best approach to learn the framework, because we are all different, and some of us prefer books while others prefer video tutorials. I think it really depends on you, so I'll keep it short, but my answer is I think it depends. No. So in terms of your questions which are not related, please send them in comments afterwards on social media, and let's discuss them further separately, okay? Not to impact too much this video. Okay, and I'm now going to the repository. You observe here, because now I'm actually implementing, I'm writing my own repository implementation. You see that I'm defining a class, and then I need to use a stereotype annotation to make sure that in the Spring context you have an instance of this class that you can inject. For example, in my case, I need to inject it in the controller here. Good. Problem is, problem is, many developers don't really understand this repository annotation here. And then I've seen so many times developers using Spring Data and then using the repository annotation over Spring Data interfaces. You will learn that in Spring Data we do not write implementations anymore as I'm doing here. So the repository that the application uses will turn from a class into an interface. And then I still see developers using the repository annotation. At that time I will tell you this is wrong, because doesn't bring you anything. So remember, we use the repository annotation when we implement ourselves a repository, so a class that defines some repository logic. Then it makes sense because you need to use a stereotype annotation such that you tell Spring to create an instance of this class into its context and then be able to inject it wherever you need it. So in my case, in the controller. For that, please remember to review chapters 2 to 5. They are very important. No, the part that we have discussed here about beans, context itself, is the solid foundation of everything that Spring is. If you don't properly understand everything that we have discussed in chapters 2 to 5 and 6, of course, the AOP later, then without this part 1, the fundamentals of the book, just understanding some things from the second part will not make you a Spring developer. This whole book, it's about understanding the behind the scenes. Even this part 2 here doesn't teach you only to create some applications, and it doesn't even have that as a primary purpose. If you want to discuss directly building applications and not the behind the scenes, there are other books for that purpose as well. But remember, never go to that direction before understanding the basics. Only by understanding the basics you will be a real developer who is able to implement, make decisions of implementation, make decisions of architecture, and troubleshoot in any kind of situation. If you don't know the basics, you will not be able to take such decisions or be comfortable with working in any scenario. You will only be a simple little robot replicating, copy-pasting, or replicating some functionality. And this will mean that you either need guidance forever, and you don't want that, that's not your target, or you potentially will implement applications which are not that good as you would like to. So look, this is an implementation. Now what do I do here? I inject the JDBC template, and then I will use this JDBC template. Where do I have the JDBC template from? Well, the JDBC template appears in the context simply because in the Maven we have added this dependency here, the Spring Boot Startup JDBC. So this is what enables our JDBC template to exist. Of course, we can configure it and customize it if we want, either through a configuration file or in the application properties or application YAML. And then the simplest thing that you see here, we can store an object of type purchase. So we still have to create the query and then call an update with the query and the parameters. You can compare this now with the snippet I've started with, and then you will see what a big difference is in terms of readability of the code. No? So you don't need 7 lines of code and treating an unnecessary exception. The only thing you need is a couple of lines of code. No? So it's defining the SQL query and then making the update. So it's a much shorter code, much readable code, and it's still low level, but it eliminates a large part of the verbosity that comes from the JDK. Now, of course, this is simple, no? But what happens when you want to retrieve values? So now it was easy because I have the query and I simply just, you see, I give the query and then I enumerate as many parameters as I want, and then the JDBC template will automatically know to replace the question marks here with the values that I provide. But what happens in case of a select query? Well, if it's a select query, it's a little bit more difficult because, well, Spring can't know exactly how to map an object to a table from the database. You can just say select all the projection from the database and get it. And then that's why when we have a select query, we are dependent also on a row mapper object. The row mapper object, it tells Spring how to map a row in the database to a model object such as purchase in our case here. So look on this diagram how it looks. JDBC template will require a connection through the data source, which of course only requests a new connection if it's needed. No, that's its purpose. That's what a data source does. That's what we discussed at the beginning of this episode. The JDBC template gets the connection, sends the select query, gets a result set back, and then it uses a row mapper to map the result set to a list, to a collection of purchase instance. Basically, each row from the result set will be mapped using the row mapper into a purchase object in my case here. So this is how it will look like. This is an implementation of the row mapper. In my case, made for simplifying the things, made through a lambda. But I do recommend in real world applications, if you have something like that, to prefer a separate class because it makes things also easier to unit test. But now, what does it actually do? R here is the result set. I here is the index of the row in the result set. If you have an idea of the Java fundamentals, you might remember from it's basically somewhere around the final chapter of the OCP where you learn how to parse a result set. You need to use a while, and then you say while the result set still has values, get the next value, and then from the next value get the index from the particular column or something like that. So this is basically what this is doing, is you provide the logic that is inside the while. Imagine that. Remember that while, and now what you do is actually is like you provide the logic inside the while. And what do you say here? You say, okay, create me a purchase object, and on the ID I want to get from the result set what's on the column ID. On the product get me the value from the result set from the column named product. On the price, get the value from the result set from the column named price. In this case particularly, I didn't need a row. No, I only needed to map the values, so it's the same logic for every row. No, if you have a situation where you need to have an particular logic based on the index of the row, it's provided to you and you can use it. If not, you can just spare it, and that's it. And then to get a list of objects, you simply call the query method with the query, the mapper, and eventually now it's not the case because this selects basically everything from the table. But if you had some where and some question mark with a value on the condition or something, then of course you would have had also provided the values for those parameters. So this query now automatically knows how to apply this logic in that while loop to create a list of the retrieved purchase object and then return it. So it's pretty simple. Again, if you compare it to what retrieval looks like using plain Java, vanilla Java, then this is a huge enhancement. However, we are still better today than this is. This still happens behind the scenes today, but we want to have our applications even more, even cleaner, eliminate even more boilerplate code. We want to have as least as possible write the minimum amount of code to get this. And in chapter 14, when we get into Spring Data, you will see other techniques that we can use to avoid even the necessity of a row mapper. You will be able to eliminate this by allowing Spring to parse the model objects and use annotations to tell Spring what to map to what exactly to map. So, of course, to conclude with this and have an end of this example, I have created also the controller class as we have learned in chapters 10 and 11, no? And then now you have a complete solution. If you run this example, you can do that. You can download it from the main page in Manning, run it, and you can use Postman, Bruno, or CURL directly or anything similar to add some new object in the database and then get the objects, and that's basically what you get, the list of the object in this case, or objects that you have added. Okay, I will quickly go, and then before ending this session, quickly go about through the customization of the data source, because remember at the very beginning of this episode I told you that you can customize the data source. So you can do basically this either through a configuration file or in the application properties file. Now, like this, you have the Spring data source prefix, and then you have all the parameters from the data source. Here you can basically configure things like number of connections to be kept, parameters that can influence even the way your application behaves, sometimes useful for enhancing the performance according to the behavior of your application. Sometimes it's better to have less connections, sometimes it's better to have more connections. So remember, the data source pre-configured by Spring Boot will give you a value which is the most common, which we call the convention. But also remember that this doesn't always fit to precisely all the applications. So remember that you can basically use always either a configuration class or the application property, the properties, or a custom data source being in the configuration class. This is how it looks like. See, so you can define the configuration class, and if you define a data source bean, this will automatically override the existing bean. And now I'm still using Hikari data source here, where I can set what parameters I want, timeouts, number of connections, so on and so forth. But I could have used some different implementation. Again, you are not forced into using always Hikari, even if, trust me, it's probably the best now. But again, Spring is flexible. It allows you to use even your own implementation if you want. Any data source implementation has its main class implementing the data source interface here. So this is the data source interface, is the one representing the contract that we expect. So you will have to basically always return something that implements the data source contract, and that something is the data source implementation. And this is how you can even programmatically implement some optimizations. Now you can define some rules, some programmatic approach in which you decide to set the, I don't know, connection timeout. Can be 5,000 or 1,000 depending on, you know better what. It's a programmatic approach. You can use an if and an else here and implement whatever logic you need. And that's basically it. I don't want to keep it longer than this. We are already here with have spent this hour talking about data sources, mainly, again, about the very, very basics, about maybe things that you will not necessarily touch a lot directly, but that you need to understand today. Is very dangerous that the majority of the developers implement apps with Spring Data without really knowing what that interface really is and what does that hide behind the scenes, because this is why I have seen in so many projects lately n+1 query problems, queries that don't use adequate indexes, reads of different values that are not necessary, which might impact the performance. Many problems, because Spring Data, as you will see, as we will discuss, is very cool. It does a lot of magic behind the scenes, but you need to be the wizard. You need to control that magic. It's not magic you look at. If you are not a wizard to control the magic, then the magic can overturn you. So what I want, and the same thing I'm stating throughout this book, but also I've been saying throughout this entire series, and I will continue to say, is that you really need to understand what's there out of those basics. So, and one more question I have here, I think, and then I will end it. How do things change when you use something like Juke? Juke is another framework. They do not change a lot. The data source still exists even with Juke, because Juke uses something to send the queries. But it's a different way of writing the queries because it's a programmatic way. It's kind of looks like more like criteria query on steroids, in case you've actually ever used criteria query with Hibernate. But in the end, it's still, this is more like part of the application logic. It's just a different way to build the queries. Instead of writing them as strings and replacing the values, you have a programmatic approach to build the strings. Can we have a data source that changes its configuration at runtime? Yes, that's what I was explaining here. That being that you can actually have a bean, you can basically use programmatic approaches to change the bean with one another. There are different ways in Spring. It's either here you can have a logic of your bean at runtime. Now, so not at the creation, probably. You mean what? You mean during the execution? Well, you have access to this data source anywhere. So you can have even a controller controlling your data source. So I guess, yes, unless the implementation is immutable, which doesn't depend, like, I don't know if Hikari is immutable, to be honest. I've never tried to use that. But unless the implementation is immutable, you should be able to do that. But to be honest with you, this is something like very unusual. I wouldn't say I've pretty often seen something like that happening. So like the URL. But what happens usually is that you might actually decide the URL when creating the data source. That's very, very often. Now you see here, for example, the values are taken from environment variables. And this is often because, for example, you can have multiple environments, dev, test, demo, production, and then definitely the URLs will be different for those. Okay, friends, it's already late. We are 2 minutes past the time, and we still have anyway time in the next episodes to discuss. So note down your questions and let's discuss them together. And of course, you know that you can find me as well on social media. When we meet next time, we can talk about these subjects as well. Anyway, we'll continue with chapter 13, which is actually still on databases, so pretty much a lot of time to discuss all these details. But until then, I hope you have a wonderful time for learning and stay tuned. Cheers, everyone.